So today we're gonna talk about finding the area of a cylinder. We're gonna calculate not only the lateral area, but we're also going to calculate the surface area. The lateral area of a cylinder is going to involve only the sides of the cylinder. So if we have a cylinder, we can think of a cylinder as a soup can. It has congruent bases, the top and the bottom being circles, the same size, and they are parallel, just like in our other figures. And then they're connected all the way around. So again, think of a soup can when you're talking about a cylinder. Our bases are going to be the circular figures of that soup can. So our bases are what we need to find the surface area. Remember, surface is the face plus the base. In a cylinder, we really only have one face, and these pictures of toilet paper rolls can help us visualize that. So because we don't have any edges on the toilet paper roll, we don't have multiple faces. We really only have one face. And you can see if you cut the toilet paper roll open and lay it flat, it's just going to be one big shape. What shape is that going to be? Well, none other than a rectangle. So if I were to cut this cylinder right down from the top to the bottom, just like we did in this toilet paper. They cut from the top to the bottom. When we open it up and lay it out, it becomes one big rectangle. The dimensions of the rectangle are going to be as tall as the cylinder is. So if my cylinder was 10, then my rectangle would also be 10 in terms of the height of the rectangle. Now this is where it gets tricky. What would my length be? How would I find the length of this rectangle? Well, again, if I cut it straight down the center and I open it up, this entire length is going to be the same as this entire area all the way around. So from right here all the way around the circle, stopping right here. What do we call the distance around a circle? Circumference. Circumference. So this length of our rectangle is going to be the circumference of our circle. Our circumference is 2 times pi times r. So in order to find the length of our rectangle, we need to know the radius, 2 times pi times r. So that's just to find the lateral area. We're just finding our rectangle. For the surface area, that's finding everything. So a toilet paper roll wouldn't be a great surface area because there's this hole in the top. So there is no surface. But a soup can would be a much better example of a surface area of a cylinder. Because again, we have our two bases made of circles. And those will be the bases, and then the one face, which is going to be the surrounding parts of the cylinder. So here if we have a soup can and we want to know what is the total aluminum that we're using to make this can, we would use not only the bases, which would be two circles, but we would also use the face. So our face is going to be a rectangle, just like we did for the lateral area. And then we're going to find the area of that using whatever the height is, and using our 2 pi r for the circumference. The bases are going to be 2 perfect circles, the top and the bottom, and to find the area of those circles we use pi r squared. So cylinders get a little tricky because now we're using both formulas for the circle, so we have to know where we're using each formula. And we're going to add those two things up to give us the total area or the surface area. So let's do a few examples and put this into practice. Here we have a circle, our cylinder. We're going to find the lateral area first. So the lateral area is going to be all of the part around. Again, think of the toilet paper. We want to color in all of the area around, not the bases. So again, we know that when we cut our toilet paper roll right down the center, it's going to open up and give us a rectangle. So here we have our rectangle. Using the information from the figure, we can see that our rectangle, or our cylinder, is 6 inches high. And then we also know that this is going to be the circumference of the circle, which is going to give us our length of the rectangle. So our 2 times pi times r. Do we know r? Well, we know our diameter is 8, and our radius is going to be half of that, so our radius is going to be 4. So we can plug to find the circumference, which is 2 times pi times our radius, or 8 pi. So our length is 8 pi. For cylinders, to make our answers easier to read and less complicated with a bunch of decimals, instead of using 3.14, we're going to just use pi and keep the symbol. So to find the area of our face of the cylinder, we're really just finding the area of a rectangle, which is length times width. The area of the rectangle is the length, which is 8 pi, times the width, which is 6. Again, we're going to leave our answer in terms of pi. So really we just do 8 times 6. So our final answer is 48 pi, and we'll label that as lateral area. Now our surface area is just going to be our lateral area plus our 2 bases, which again we've discussed are going to be perfect circles. So we want to find the area of both of these circles, the top portion of the cylinder and the bottom portion of the cylinder. So here we need to use the area of a cylinder, the area of a circle. So our surface area, we need to use pi r squared. Here we know, again, our radius is going to be 4, so we're going to use pi times 4 squared, which is 4 squared, 16 pi. So that's the surface area of one base. We need to find the area of 2 bases. Since they're going to be identical, you can just multiply times 2. So it's going to be 48 pi plus 2 times the area of the 2 bases. So 2 times 16 is 32 pi. And again, since pi, we can treat it somewhat like a variable. It is a like term, so 48 plus 32 is going to give us 8 plus 32, 0, 80 pi. So our total surface area is 80 pi, our lateral area is 48 pi. Right? So this one was a little tricky because they gave us a diameter. Sometimes they'll give us a radius, so it did require a little extra work, and we need to pay really close attention when we're doing these problems. Do I have a diameter, or do I have a radius? Both of our formulas for the lateral area and for the surface area require us to use the radius. So we always have to double check that that's what we're plugging in. Our second example, here we have a cylinder. It's tilted sort of on its side. Again, if we want to find the lateral area, we need to think of the toilet paper. We can cut our cylinder right in half. Again, we want to cut from the base to the other base. And we're going to get a rectangle again. And now maybe we can think, alright, our rectangle is going to be a little bit longer this way, because when we flatten it out, it'll open the long way. So my height, or my length of the rectangle is going to be 10. And again, the length of my rectangle is going to be from the circumference of my cylinder. So again, the formula for circumference is 2 pi r. And we are given the radius in this case, so we don't need to do any extra work. We can just plug it in. So 2 times pi times 2. We can multiply 2 times 2 to give us 4 pi, which is our circumference, or the length of our rectangle. So to find the lateral area, we only need to find the area of the face. So again, we're going to use the length times the width, since it's a rectangle, 4 pi times 10. So my lateral area is 4 times 10, which is 40 pi. And again, leaving our answers in terms of pi, just going to keep our answers a little bit neater. And so that's what we're going to use for our cylinders. And then the last thing we're going to do is the surface area of this cylinder. The surface area, again, we've already done most of the work. Now we just need to add that to our two bases. So again, my bases are going to be circles. We're going to have a radius of 2, as they've shown us in the diagram. And so for area of one base, it's pi r squared. So we know our radius is 2, so pi times 2 squared. So our area is going to be 4 pi. And again, 4 pi is the area of one base. We have a top and a bottom, or in this case a left and a right. So we want to have our 40 pi from the lateral area added to 4 pi, which is one of the bases, and 4 pi, which is another base. So 40 plus 4 plus 4 is going to give us 48 pi for our surface area. And that is all for the area of a cylinder. Bring these notes in to class tomorrow and be ready to do some more practice.